Hi, my name is Zach Lassiter, and today I'm going to give a brief lesson on combinatorics and other basic counting principles. First, I'm going to talk about permutations. So permutations are fundamentally the number of ways to choose and order a number of objects in a given set. Some key points to remember about permutations are order matters. It's denoted as p parentheses n comma k and read as k permutation on n objects. Additionally, it always equals n factorial when n equals k, and we'll see why that is later in the presentation. To go over the concept of permutations, we're going to just discuss a simple problem where n equals k. In other words, we want to know how many ways can we order n objects. And here's our guiding problem. So Northeastern is putting on an end-of-semester parade that will march through campus. 6 clubs have been assigned to manage their own exhibit in the parade. Jake, the parade coordinator, is discussing the order of the exhibits with his friend. How many different parade orders are possible? Now, to go about solving this, we can best intuitively reason through it using the multiplication principle. So for our problem, each of these lines represents the order of the parade. So here's our first position in the parade. So you can see for this, the first position, we have 6 options. And after that, obviously, we have 5 options, and so on and so forth. So we can see that to order 6 objects and these 6 exhibits in the parade, we have 6 factorial. So we can see that when n equals k, a k permutation on n equals n factorial. And in other words, the number of ways to order n objects is n factorial. So how about when k does not equal 0? So we can consider our same situation with the parade, but let's say now Jake must choose only 3 of the 6 clubs to parade around Northeastern. So now we are looking for the 3 permutation on 6 objects. So again, we have our order. For the first position, we have 6 different options, and the next we have 5, and then 4. So our final answer for the 3 permutation on 6 objects and the number of parades, permutations of 3 parades of 6 clubs is 6 times 4 times or 6 times 5 times 4, or 120. Alternatively, if Jake was told to choose 7 of the 6 clubs to participate in the parade, or if k was greater than n, then 0 arrangements are possible. This is fairly intuitive, but it is also an important thing to remember. Now, let's talk about the permutation formula. So here we have our k permutation on n, and we can see that that's equivalent to n factorial over n minus k factorial. If we plug that in to our problem, we have that the 3 permutation of 6 is 6 factorial over 3 factorial, or this big long thing, which you can see this just cancels out to 6 times 5 times 4, which is what we got when we were reasoning it out using the multiplication principle. Alright, now let's talk about combinations. So combinations are the number of groupings from a given set of objects. Some key ideas to remember about combinations are order does not matter. It is denoted like this, and read as n choose k. Since order does not matter, there will always be, well, for the most part, always be fewer combinations than permutations. To touch on this subject, we're going to consider an example problem. So consider a school-wide high school dodgeball tournament. Each homeroom must enter a team of 8 students to compete and represent their class. How many unique teams can the class possibly put together if their homeroom has 20 students in it? So we can see that order does not matter here, and this is clearly a combinations problem. So here's one example of a combination. Here's our class of 20 unique students, and you can see that we're just selecting 8 out of the 20 to represent one team, and order does not matter. So how do we go about solving this? Well, let's first consider it from the standpoint of permutations. So if we consider the 8 permutation on 20, we said earlier that the number of combinations is, for the most part, always fewer than the number of permutations. So by how much are we overcounting? So in our set containing all the permutations of different teams, Each team combination appears as many times as there are different orderings of 8 objects. So earlier we concluded that k objects can be ordered in k factorial ways. Thus, we are overcounting by 8 factorial permutations per valid combination. So now if we try to derive a formula, it follows that n choose k equals the k permutation on n divided by k factorial. And if we just extrapolate that, we get n factorial over k factorial times n minus k factorial to be our formula for n choose k. So if we plug in our numbers from our problem, we get that 20 choose 8 equals 20 factorial over 8 factorial times 12 factorial possible teams. And we'll see that that number is much less than the number of valid permutations, the 8 permutation on 20. Thank you for watching the abridged version of this lesson. If you would like to see another example problem and an overview of a few more niche counting concepts, then please watch the full version. Thank you.